Okay, 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 okay. Ah. Oh, I lost the control over my stream right now. I'm sorry. Hi guys. Let me play some music. Hello, Wonderly. Oh, yeah. Okay, some signature music here. Where's the image? There's the image. Okay, let's start all over again here. Okay, Party time. Ah, hallo Bitbastlerei. Oh, I have like just I just uh, I'm using like now like this live streaming studio, and oh, I'm in the wrong channel here. Sorry, I it was so spontaneous that I'm not very well prepared right now, but I will start immediately. Let me just gain control over my stream again. No, it doesn't show anything. Where is my live stream? Am I back here? Yes, this one. Okay. uh, I hope the audio is okay. We have quite some storms outside. If my voice pitches to like an octave lower, please tell me, then I have to restart my H6. It is a little bit buggy sometimes, and it simply just turns down like the pitch. I don't know if it has something to do with the sampling rate. Okay, I have the chat here. Maybe I can show it also on screen. Let me set this up. Where is this? This is the URL for the chat, and I only want to show top chat like that. Does it show anything? Okay, yeah. Community guide, it's German. Okay, so chat seems to be working. And yeah, I was like doing PCB design all the time. Oops, this not sharing the wrong window here. Okay, so we have like this here. To set this up properly, my face goes, oh, this is the chat. I'm streaming in full HD, but my screen is 4K, so I hope. No, you probably won't be able to see all my tabs, and but it should be okay for the, at least for my face is too huge here, like that. Maybe I put it down here. Okay, so what I've been up to right now, so I'm if you watched like the last MakerCast, I already was talking about making MIDI synthesizers. I don't know if I can show off right now. I would have to power this up. Where is it? But what I... Hello Martin. So I was working for the MIDI synthesizers. You need to check out the last MakerCast. So I even showed off. I will maybe show off later. We have like 2.5 hours time now. I was using like my this is my development board with, it was like a mini computer, and it has this USB host ports. I would make it big, make it face like, okay, yeah, this here. So it has the USB host chip there, which I've been showing off on the latest videos. So I'm capable of like powering and driving USB devices. And if you know my channel for some time, I started even with USB, not with USB, but with MIDI devices. So music is very important in my life. I'm not very talented or teached in like playing an instrument. I took cello lessons when I was grown up, and that isn't working out very well. You have to start as a child to be good at the end. So I stopped it at some point, but I would really love to play like keyboards and so on, and I love to play around with synthesizers, and I'm doing like some music stuff with a friend of mine, and I'm like this crazy dilettante that only rotates some knobs until it sounds okay, and then that's all I can do. And one of the first, it was actually the project that I started this channel with 8 years ago. So this was this MIDI organ pedals, and I made, there's something missing, but yeah, I etched the boards myself back then. Focus. Yeah, here we go. I etched the board myself. This is an 80 mega microcontroller, and I can't find the multiplexer board for this. That was quite some work. It's like, I don't know how many nodes these are. It's like maybe 28 analog channels with Hall effect sensors. Hi, Giletronics TV. It was like many analog inputs with the Hall effect sensors that I used, with even some velocity to get like MIDI velocity of the keys and so on, and aftertouch. But I think I never implemented aftertouch, polyphonic aftertouch at the end. Nevertheless, I also built like an Arduino synthesizer already. It's a quite old series. It's still okay, I think, to watch. It works with the old Arduino devices, but I also did one. I never released that one. It was like on a ESP8266, and now that I'm like all into ESP32, I thought, okay, maybe like revisit like a Arduino synthesizer, especially since I have all the keyboards, whoops, all my MIDI instruments that I use right now all have. So formerly this DIN connector was used for MIDI. That's simply an UART with like 56 kilobits per second. And I have now all my small devices have only like USB, so that doesn't work anymore unless you get like some host device. Do I have the host board here? Yeah, I think it's already 2 years ago that I showed. Nobody saw this video because it's like 10k views only. So I used like this host board that's using like a PIC microcontroller that converts a USB MIDI to serial or I2C, I think. But this board's deprecated. It isn't sold anymore. It was like below $10. And since I'm working now with You want a gift? Okay. Yeah, I'll be there on in Hanover. I think so. We didn't plan Hanover yet. Berlin. Berlin is the next in the line, and we will be in Berlin. And after we're done with Berlin, we will plan SuperCon Belgrade, and then after that, I think Hanover. But I will have like one thing uh, for Hanover that will be better than your small card. Oh yeah, cool, Martin. So yeah, reach out to me and we shake hands and maybe talk a bit. Um, so, where was I? So I wanted to, since I'm doing like this MIDI, this USB host stuff. Focus. Yeah, this is this IC here, this quadratic IC. I'm using it with the ESP32 now, but you could use it with any other microcontroller. I started to implement like drivers for several devices. I shown this with the game controllers already, and then I thought, okay, let's take a look at MIDI, and I started to implement this, and I got like it is compatible with 80% of all my MIDI devices already. So I have like mixers, launch pads, like this ones and this ones. They are recognized, and I got all the input from them to my ESP32. But device like this, I have to check. Like there is like this negotiation and descriptors that you have to analyze when the device connects on the USB, and to get this everything right and pick the right endpoint to communicate with. There needs to be some logic, and so I will, let's say, implement this progressively, especially at the point when I want to like provide like boards, since it's quite complicated to, if you never did something with these, and if you don't have like a development that I can, do I have one here? Yeah, okay. So you, with this IC, this CH559, it's like this was my first thing. I just soldered it on a breakout board and added a button and an LED to be able to program it, and like soldered like only the two connect USB connectors to it, and that actually worked. And I have like this is like a serial converter, so I'll be able to communicate or see the debug output of this. So this is like set up in an hour, and this is how I started. But nobody will do this at a lower like hobby level. Nobody will try to do it, or maybe, and it is tedious. Oh no, I'm not a Google fan. It's just comfy. That's why I didn't dress properly for the stream, since it's so spontaneous. Yeah, I set it to slow, since when I like leave it like that and will talk all the time, that's the best, and you won't have this focus hunting. Okay, nevertheless, what I want to do is like to provide cheap USB host boards for the ESP that you are capable of using with even like audio stuff. So I have one here. No, that's not the right one. Yeah, so I want to design a few boards. This is like my mini computer. It has the SD card and the VGA, which isn't really needed, and it has like the Silicon Labs IC that's a little bit more expensive than the CH serial for the programming of the ESP32. And I thought, okay, let's do like a smaller board that you will be like able to use it on the go with like a power bank or something, and get like a simple headphone jack on one side, and on the other side like the MIDI inputs. So hello Shrikant Nikam. So let me share the screen again. I'm using Easy EDA. I was try mouth here. I'm using Easy EDA for designing my boards, since this is the only I learned, or I used, like, which was but that's long time ago. And since I was and am sponsored by JLC at some point, I still use Easy EDA. It's quite simple, and I don't have to. What I like is the parts library, that you have like the huge community, and there is always like some kind of footprint and schematics for the parts. So I use this online tool, and that's always like up to date. Oh yeah, that's Crystal Beer. Hi Dave. Oh, I didn't post the link to. Oops. Oh, no! Oh no! 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 Ah! Sorry. Oh! I shouldn't have shown this. Let me switch. Missed. Yes, it's like our Discord group. Oops. Kai Cat, okay. So where's the link? I will share it to my friends in the Discord. Okay. And I will end Discord. Okay. Oh, yeah, showing the wrong windows all the time. No, not. Yeah, I think I didn't spoil any information that. No key, yeah, all the keys are. This time I tried to set like the super low latency, so we can really chat on the stream. I can show the chat window again. Yeah. Oh, nice. That's even up to date. Maybe I will scale it a bit. Yeah, there is no like filters or something. Scale it a bit, so cool. So we have like the chat window here. Is it working? Yeah. Yeah, it's not monetized anyways, since I need some watch hours on the trash channel, so naked people are fine in the background. Oh yeah, no worries. The parts are quite okay to solder. Yeah, but the of half millimeter pin pitch of the hose is the most difficult to solder. So I get some solder bridges there. Um, but you can like if you move like the soldering iron, use some flux and move the soldering iron like away from the chip, you will drag the solder bridges away, and they will stick to the tip, and you can clean the tip. So this is how I get the solder bridges. This is all like I don't think that I have a stencil for that. I might have even soldered it. I might have a stencil. I don't know, but that's whole that whole thing was hand picked. I don't use like O4 or 2 parts, only O 06 or 03. So I'm able to work on my prototypes and maybe botch them if needed. Hello, Brian. Yeah, there is no way I will make money on the only thing that Super Chat could help me here, but I don't care. That isn't quality work that I will provide here on the Trash channel. So don't expect anything. But once I hit like the 4K hours watch time, I will immediately like bombard you with all the ads. Yeah, maybe I will stream it, but it's always like a mood thing, and I'm currently like a little bit. I feel like a bit guilty that I didn't release a video for such a long time. And I'm in the mood to stream right now, so I felt like spontaneously streaming. But if you, I have like several. This is the new script that I started, and I have like an old script. So keep the spelling errors. It doesn't matter for a script. And yeah, I this is the script that I wrote. It's very detailed, and I stopped at some point and I thought, now, okay, do I really need to go into every single detail, or like do really elaborate um, video about from the start to the beginning of designing MIDI synthesizers, or do I like start with designing synthesizers or how synthesizers work and all the wording that is done there. So I'm really undecided how what kind of video I do want to make right now. Oh, the last video is like over 3 weeks ago. Yeah, it takes much longer, but I can. Um, I actually even I could even use your help, since there are some experts in watching me. I was like on Friday, I was really struggling. I tried to fix my issues with. So I have this analog video PAL working with the internal digital to analog converters, and now um, I want to get it working with the second I squared S channel, since I can use 8 bits there, and I have even like a fast buffer and this R2R resistor bridges and ladders, and it simply doesn't work. The color carrier doesn't work, and I'm really struggling with this. I found out that if I change like the sampling rate by a bit, I get like color stripes, like vertical color stripes, and if I change like the sampling frequency, they're getting wider, and but I never got it like right. And I tried some filters, and this is where I struggle, because I'm not like I don't know how to do like inductors and like do this high frequency filtering, and this is something people could help me even on the live stream. So it's better to like take twice as long on the live stream and get it finished than taking like 10 times longer and give up at the end, like it happened to me on Friday and 2 times before when I tried with that. Yeah, yeah, Charles. I don't know if Charles is watching. That's not. He's probably sleeping right now. He was streaming like this Vive, HTC Vive stuff. Oh yeah. Okay. Ah, yeah. But now China. Uh, Other news. Other news. Maybe I will show it off. Can you spot it in the background? Let it focus. No, it won't focus. Oh, it loses the focus. Ah, here it comes. Yeah, there it is. Ta-da! I received it this week. Ah, look what I found on the floor. This is like an older version of the multiplexer board. I don't know. Yeah, whatever. So from the MIDI organ pedals. That was like a two-sided self-edged board. So I had to align all the wires and put like a small wire through that. Okay. So now we got some people watching here already, and I will maybe fill you in what I have done. Take a look at my projects here. MIDI synth master. Okay, now so what did you have? What did we have so far? So the board that I was using for my synth is this one here, and this was VGA Blue. I think that was the working name here. So I will share a bit of my. That's like two sheets. This is the host part, the USB host part, and this is the ESP part with only like 6-bit VGA here. And obviously we don't need the VGA part, and I could do some cool output on the VGA, but I want to start simple and maybe grow it. If someone is interested in MIDI, then okay, or synthesizers, then okay, but I don't know. I'm not sure about that. So what I took, like I took parts from this blue edition that is actually green right now. And I took parts from my camera programmer. That was that one. Yeah, because I used like not the Silicon Labs, but the cheaper CH340 serial converter, and I took parts. No, I created even a new part. But I'm still waiting on. I probably on Monday I will get my LCSC shipping with some audio amplifiers. Oh yeah, Brian, have fun with your video. I started my channel. I think it was like, it will be like 8 years ago now. 7 years, 8 years, I don't know anymore. This year in August it will be 8, I think. But yeah, I wasn't working like full time on that channel for all the time. I'm working on full time since 2.5 years, something like that. Yeah, but I took some contractor work to survive since yeah, it wasn't much money in the beginning, and now I barely survive. Okay, so what the problem with this board or all the boards that had like an audio jack before, that this is only line out. So I had this audio jack also on the tiny Pico VGA, the Pico VGA. Yeah, I will just here focus, or whatever, not important. And it doesn't have a buffer, so it's like, or it isn't like amplified. Like I'm not into this stuff. Like you have like A, B, C, and D amplifiers, and class A, B class. Like I had only like this output from the digital to analog converters connected with a cap to get rid of the DC offset. So that's how analog works. Only a 10 microfarad cap, and then the audio jack. And the problem with that is that you won't be able to drive any headphones with that. It's not enough power. It's like a few milliamps, and certainly that isn't enough, especially with the filter cap in between. For some reason, probably you need like some electrolytic. I'm really not knowing how that really works. Class A amplifier. Yeah. What? Ah, you're welcome, Shirikant. Class A amplifier for headphones. So, I want to fix that problem with a new board, and I want to use a Class AB amplifier. That is not the right board that I want to show you. So, this is the new synthesizer board, and I found on LCSC what I really hate is like this output filter. Maybe I can show the blue edition here. So here you can see this is my left channel, right channel, and I call it DC. So this is coming in, and here's the filter cap, like this if the most linear and less efficient type of amplifier. It's okay for low powers. Oh, okay, great. Yeah. I should really take some time to learn about this stuff. Yeah, but I'm quite lazy and doing like stuff that I really interested right now, and I'm not really interested in taking like electronics classes. If Curiosity Stream or how are all these lifelong learning platforms, if they contact me and offer me a sponsorship, I will take a class on that and I will do the sponsorship. But and I hope you help me with all this amplification stuff. So so I wanted to fix that issues that I couldn't drive headphones before. And I was browsing through LCSC to find an amplifier that has like a capless output. So where's the output? Here's R and here's L. And maybe I have even can show you the part. This is the amplifier that I found. I was looking at it for hours. I was looking like, I never heard of that company. and it's an affordable amplifier. And since yeah, analog devices like quite expensive, and they have like really sophisticated and complicated circuits around it. I don't want to have many parts. And what does it say? Can I zoom in here somehow? Yeah, zoom in here. So what is it? Here, that's the important part. Patent pending. Okay, yeah, whatever. It's like they have like a charge pump. So they, if you want to amplify like audio, and you need negative voltage, and the charge pump inside of this, you don't need many external components for that, only some caps. Have like a built-in charge pump, so where when they are amplifying, also amplifying negative voltage. So, dear sir, can you help me with some USB hit OTG device? But Android app is not stable, sometimes in response. Yeah, sorry. That's like individual project. I really can't help you right now, like with this. It's like human interface devices are so complicated in USB. It's like the protocol is so long, and you have to analyze bits and sort it out. But this is something like this is like it sounds like a driver issue. I uh, and my camera, that's that's my GH5. So that's a rather expensive webcam. It's like my filming camera. It usually uses I film like 4K with that. Hello, Andreas. Oh yeah, DSLR. Um, it's not. It doesn't. This is a mirrorless camera. I wouldn't buy a camera with mirrors anymore. They're like you get like with the viewfinder, with the OLED viewfinders, you're much better off, since you actually see the image that you will get afterwards. With the if you're using like mirrored camera, then you have like you see the image as your eye perceives it, but not like the sensor perceives it. So you rather it's heavy and it's bulky and it's huge, and you lose like some light. You want to uh, use all the light that you need, and that mirrorless. I wasn't happy with the GH5 because the autofocus was really bad, and now they've updated it like a few months ago, and it finally works that I can use autofocus with like streaming here. Oh yeah, yeah. Why I would use Canon or Sony. Sony because it's so light. It works with like the sensor is very sensitive, and you don't need much lighting. And yeah, that's really an issue with like small sensors. And this is like a for third sensor side, and you need some more light than you would if you would like an Sony Alpha 3, or how that is called. But all of the this is the only camera, like mirrorless camera, that is affordable, like not like in this I don't like red. It's not a red camera, but this is the only camera that supports 60 frames per second in 4K with like endless recording. There are probably some cameras that could like, you could use like maybe a phone with 60 frames a second and like record some for some time, but this is the only one that is able like to record for endless time. So that's why I took the GH5. Okay, yeah, but we get distracted. Back to our amplification here. So I don't want to have this caps, and since this IC uses a charge pump, I don't know if it works well, if it's okay. And this is the output circuit. This isn't very bad. So what I'm confused is like, okay, you need like a cap on the input, and I'm worried that I lose my my bass there. So the issue with the caps at the output that I had so far with that one here, that the lower the value here is, the more that's like a high pass filter. Yeah, I lose all the bass with the filters like that. That will never be able to like accurately like give you a 20 hertz wave. It will always filter that, so you lose all the low and that's like so crippling if you like want to like good music, and it's a little bit disappointing. So I wanted to get rid of these. And no, that's not camera. So this is that's not the one. So why I took I wanted to pick an amplifier that actually has a built-in charge pump and does all like filterless output. It's simply connected directly to the audio jack, and you can drive headphones with that. So what do we get here? Is it like pop? Do we have some specs here? Let's try to read the specs. Output power per channel. Okay, you get like 35 milliwatts or 25 milliwatts depending on the on the impedance here, on the resistance of the headphones. But I don't know how that works. I will try with this IC. Maybe I bought too many. I have how many do I order? I have like a number. Yeah, 110. Okay, that was $30. $34. And I hope they work with like for headphones at least. Okay. And yeah, I will try that. So as soon they arrive, I think on Monday, I have like a tracking number for that. And it told me, the tracking number told me, it was even sent out during like the shutdown. So I don't know, it was it was still like New Year's, Chinese New Year's stuff when they send out this packet. So I'm glad I'll be able to try. Like I usually would like simply order a board and then solder it on the board and fix that if it works or not. I wouldn't care much. But now that China is like shut down, it takes some time. So I would rather solder that on like a breakout board and test it, the whole circuit like it is right now. Test it and fix issues and have it working from the beginning instead of iterating the boards. Okay, so the changes here are now that I have like, here's the L channel and the R channel, and we have, here's the audio jack, and it's simply directly connected. There are quite some caps here, and I think I used the wrong type here. I have to yeah, that's like the wrong package. Oops, you can see that because, oh well, oops. Can I somehow, no, I can't, I need to hide the chat. Okay, so, oh yeah, you won't be able to read anything here. If you're, maybe I should, can I zoom in here? Ugh. Okay, okay, like that. Yeah, that's the wrong cap. It's like radial. Yeah, no. Yeah, I have to swap this with some. Okay, let's before I forget this, I will do it right now. Otherwise, we have to change. So EEV library, and then I pick like, okay, here's the right cap, 0603 already. I will turn your chat again on. Okay, and I will swap these. 1 micro is even correct. Nice. Okay, rotate with R. So knowing the key combinations, or at least for rotate, is way more convenient here. Yeah, I move the labels a bit. Okay, like that. Which ones? Oh, this is also wrong. Okay, so we need to change that, and that should be 2.2 microfarads. But I think that's a simple filter cap. I could also use a 10 microfarad there. So any objections, please? So important, so natural habitat, yes. Hello, knowledge dosage. Hey, cool. That's a cool channel name. Do you have a channel? Sounds like a channel, science channel or something. Talking about, yeah. Are you talking about Teslas and like? Oh no. Yeah, maybe you pick it up at some point. What was your topic? Oh, yeah, you made robot arms. Oh, cool. Okay. So it was rather a maker channel, not a science knowledge channel, like with stock footage and talking about like recent discoveries and. Okay, so guys, I need your opinion on that. I have like, this is the reference circuit that I got from the sheet here. It says I need to filter cap. Where's my, it's not the right one. Yeah, here. There is the 2.2 microfarad cap. I think this is only to smooth out the power input. Oh, thanks. Yeah, I would knowledge dosage. I encourage you, if whenever, if you have some time at some point and you are not satisfied with what you do, just pick it up again with your channel. It's like, you can ask Brian Luck. He also like I forced him to pick up on his channel or like even like publish his stuff, and now he's like also quite famous in this electronics stuff. At least we are friends now. And he sells some stuff. He's quite successful with that. Okay, nevertheless, I feel like this this is the battery power, and we have like this filter cap 2.2 microfarads. And what I'm thinking is I could rather replace that 2.2 microfarad cap with a 10 microfarad cap, because because I think it's only like a filter cap to get a smooth smooth power in, and I want to avoid having like super many different values of caps, because then you have to like have a separate reel if you pick and place them, and quite often it even costs extra to put like an additional component and stuff like that. So what is your opinion on that? Should we like keep the 2.2 microfarads, or should we like use the 10 microfarad there as well? Yeah. So at least I have like 0603. What is this? Oh, this is wrong as well. Okay, I need only to copy that one here. Yeah, this is what happens if you work in the night. Yeah, I created this circuit last night while I was listening to r/. Use the 10. Oh, Lars, cool. I will do it. I can since I will be. Oh, cool. Okay. Thanks, Buck. XY. So where are my caps? Where's my 10 microfarads? Well, I have 10 nanofarads here. There is somewhere a 10 microfarad one. I think on sheet 2 we have 10 microfarads. Yeah, here are the 10 microfarads one. So I will simply take 10 microfarads there to avoid any of you doing this like for a living, creating boards and electronics. Would be interesting to know. Hello Arduino Zone, another channel, I would assume. Oh, it's like a cool name, Arduino Zone. But why don't you have like an image or like icon? Okay, so we have replaced that one. What is that? That's okay. What I will try, I will try to get rid of this here. I think we can use DTR and RTS without this extra without this extra what is this logic gate. Oh, no worries, knowledge dosage. Supply filter cap, just ouch for the voltage bias of the MLCC caps. Oh. What? Okay. The 6.3 volt 10 microfarad cap. What MLCC? What is that meant? Is this the type, the multi-layer multi-layer capacitor, ceramic capacitor. Ah, yeah, multi-layer ceramic capacitor. Okay, yeah, I know that. There are never 10 microfarads. There's like a like 40% deviation or something like that. But I don't see a problem here with that stuff, because there is no like oscillator that depends on having the 10 microfarads. So if this multi-layer 10 microfarad isn't actually 10 microfarads but only 4 microfarads, it's still good. It's still better than 2.2. Even though maybe the 2.2 would have like a better reliable like value. And here the only other place where I use it is, this is like the host, the jacks for the USB, and these are also like only power filter caps. So there is like a 10 micro and 100 nanofarads. That's also from a reference circuit. And yeah, there is I will show it to you. Having so many caps, it's like an extra work to add them here in the schematics and maybe place them on a PCB. But it's getting so ridiculous, since you are like, it's like a huge puzzle piece, and you put different like sub-circuits together, and then you have like 10 microfarad or 100 nanofarad, especially the 100 nanofarad capacitors. You have like several that are, you have to place them close to the IC, and you have like several that are right next to each other, connected to exactly the same 5 volts or 3.3 volts and ground, because you have like this several parts of your circuit that are simply set close to each other. And then I think about it, do I even need like 5 times the 100 nanofarads for that? Or like you have, I don't know, it's like, it's a little bit confusing. Okay, so we fixed that one here. I will get rid of this. This is the programming circuit for the, that's a buffed up version. I don't know if I maybe will try, this is the rover module. So it has this additional RAM. If I want to create a wavetable and SD card slot. So if you want to work like with a wavetable, that should be maybe a pro version or something. But I designed a pro version first, and that will be more expensive, since the rover modules are more expensive than the room modules. They are even bigger, and the additional SD card slot it takes quite some space. And I don't really like to design two-sided boards, or like having the parts on both sides, since I won't be able to place them with my pick and place machine, unless I do like some kind of, I don't know, I could, but it's getting too complicated. I only want to put the parts all on one side. So the pro version will have like a rover module and a SD card slot, but I think the least people will use that in the beginning. I don't know if I will just create an Arduino library for that. It will probably a good idea to deliver like a good software for this. But I will start with only a synthesizer, like with simple waveforms and ADSR and some filters for the audio stuff. So I won't need like the SD card and the extra PS RAM for that. But I designed this anyways, and this is the current state. I will just save that. And does it save? Oops, here. Okay. And what is... Okay, these are not the ones I wanted to show. Okay, so I have another. I just wanted also to test like another version of the CH559 IC. This one because I had some solder bridges between the legs of the other IC, this dual host, and I thought, okay, I take another package of the chip to avoid like having too many pins that I won't use. And I thought, oh, nice, it's a nice idea. I will just take this package. It's, I don't know, it's not even cheaper. It's like almost like within 1% price. And I simply took the complete stock from LCSC, which was, fortunately, it was only 52. It was still like $51 for me. And and then I discovered that this IC doesn't have, isn't dual host. It is simply I don't know why they would do that. They have like several pins, but it doesn't have the second host. So there is no internal second host. I have used this board with 2 MIDI devices at once, since I want to have like some controllers like filters and so on, and then a proper keyboard with some range. No, no discussion at all if I use like the snail shipping, like that's I rarely like we have like it rarely happens to me with like this slow shipping that I will get notification from customs that I have to clear the customs or anything. With DHL that happened again, and with another order that is like being done in China right now, that will happen again too, so I have to pay customs then, and it will like even like be delayed for 1 week even if I get express shipping. So quite often I simply order the slow shipping to avoid like handling the customs for a week or for a few days. I didn't optimize that yet. Okay, so I thought, yeah, cool, I will take this one. So I have 2 host connectors, and the chip don't have too many legs and too many problems with solder bridges or anything. So it will be like less prone to errors in the production. That's what I thought. And then it appeared. I will show you the data sheet. I hope you are fluent in Chinese here. And then it appeared here. You can see both the chips. Which, oh yeah. So this one is if you can see here, the bigger one has like 0.5 millimeter pin pitch, and this one has 0.65. So it's even. It has like half, even less than half the pins that could have solder bridges, and then the distance between the pitch is even, between the pins is even bigger, so less prone to having solder bridges. And then you can see here the different packages here and the description of the pins, and then you get something like, where are the pins? Okay, here. This is the secondary host connection, USB host connection. So yeah, there is no second host on this chip. What? So Arduino Zone, do it somewhere else. You can simply not place the part and do it by yourself if you want to do that. I'm talking about Arduino Zone. So what I did with my camera programmer, they didn't support USB connectors. So I ordered without the USB connectors and soldered the connectors with hot air here in my lab. And that's what you could do if you want to do PCB assembly at JFC, or use another supplier, another assembly service for that. Okay, so unfortunately, I have now like 50 ICs around here with only one USB host connections. And but I still want to use them for some project, and that's why I thought, okay, let's do something completely different and do like a super rudimentary mini version of my synthesizer. Long story short, this is what's this one? Yeah, this is the board already. Spoiler alert. Here. No, is it that one? Yes, it is. Zoom out a bit. So this is the T version of the CH559 IC. And I thought, okay, I do the host stuff, USB host stuff, on the CH559. It doesn't have much RAM. It is really, it has really like only 2 kilobytes or even less. I don't know if it's really small SRAM and has some extra RAM. And all this RAM is already almost occupied by the USB stack. But I don't need much RAM for that. And I could use like digital to analog converter, no worries. I can use like my resistor ladder again, and it has even enough pins for that. So look at this. So we have here, this is the smaller chip, and we have like DP, that's the USB stuff. Then we have TX and RX for debugging, and then we have the I called it A for audio. And then we have like 8 bits for audio. And I took like here, you can see the labels are P1.2, 4, 5, 6, 7, and then this is P to 7 to 6 and to 5. And oh yeah, I see there is one P1.3 missing. That's inconvenient. So I have to shift around a few bits. But I think I could, like with 2 write operations to the I/O, I can set quickly like the sample. So this is simply a digital to analog converter, a simple one with the resistor ladders. And I can write like with two writes to some registers. I could set like the voltage level of the current sample. So I thought, okay, let's do all the synthesizer stuff, like a really simple synthesizer, maybe even only square wave or triangle wave or sawtooth wave, polyphonic, and maybe with some ADSR, but really rudimentary on this chip. It's fast. It's like 48 megahertz, so it could handle like even polyphonic stuff. So I can simply maybe convert a simple synthesizer, implement on this chip itself, on the host chip, and simply use one channel mono, and I have like, this is another amplifier, and put it out. This is only a mono amplifier that I bought and waiting for, and I simply, this is only mono, and I put it out on the audio here. What I don't know yet, this would be like, this is an amplifier. Wait, let's take a look at the amplifier. Let's take a look which one I ordered. Okay, so which one was this? Diodes Incorporated. That's the one. So that's another one that I just for testing, but I think I bought even 110 of these. And that's a mono amplifier. Oh, but it's a Class D amplifier. Oh, so not very linear, but you could even drive like a small speaker with that. I don't know if maybe I should include like not only this headphone jack that will blast off your headphones. No, here it says Class D. Yeah, it's a Class D amplifier, and it shows a speaker here. I don't know. No, I'm not using the Python script. I still like using only the typical programmer. But there is like news about that. I took a look at the bootloader of the CH559, and it supports also programming over a UART. I've been using the alternate UART port so far, but I will switch, if in my new boards I will switch to the first UART port, and then I will be able to program the CH559 from the ESP32 or like any other like serial port. So that will be working, hopefully. I didn't test it yet, but I saw it is possible, and this is how I want to you can use it even to over the air update to update products later. So whenever I sell like 1,000 pieces, maybe, I don't know if it's, first of all, I want to sell like maybe 100 pieces of these for the people that are interested. And if it takes off, like the stupid programmer that I did for the camera, that like already 500, like 100 people bought it and another 400 want to buy it. And if it takes off like that, the simple synthesizer, then I don't want to give support to every single person that struggles, or if I manage to find like a problem or update the driver, you have like this procedure to program it. It is simple to just press the button, and you have to like, but you have to use the special cable with like the male USB-A on both sides. So if you don't have that, you won't be able to program to update the firmware on the CH559. So it has to be, so like in the sense of providing like scaling up, it have to be like a simple update procedure for the driver chip. And then that's why I thought, okay, I have to be able to update the CH559 over the UART and from the ESP32, and that's what I will do at the end. So, but like, I always needed to make contacts with you. What? I don't get it. I always needed to make contacts with you, Great Scott, Electro Boom, and Diode Gone Wild. I don't know Diode Gone Wild. Is this a good channel? Should I check it out? I don't understand what you mean. I'm not in contact with Electro Boom, but I had some chat with Great Scott. Yeah, we are thinking it's like there is maybe a candidate for a project with Great Scott, but I won't talk about this right now here because yeah, we don't know yet if it really happens. We are quite busy, both of us are quite busy, and managing like a collaboration between, if this is what you mean, between two channels, is especially if like you're grinding through the work, is doesn't happen very fast. Okay, so I don't know if this is even, if this amplifier, this mono amplifier here, class D amplifier, will even work for headphones or like line out. Okay, back to our amplifiers. So you probably will say I will regret my decision to use this amplifier for like to drive headphones. Oh, it says like it's at 5 volts, 2.5 watts for 4 ohm speakers, and 8 ohm speakers it's like 1.5 watts. Does it work with headphones? What will happen if I connect this to line in jack? So I don't know. It didn't state that it's normally like it has like a charge pump. I assumed it. Uh-oh. So this will be like a super. Hello, Martin. It will be like a super experimental version, but I bought like 100 of these or something. How many did I order? What? 210? I'm crazy. Oh yeah, but they were cheap. It's like $21. What? 20? Oh, that will be completely overdriven then. Oh shit. Yeah, I will try that. As soon they arrive, I will try how that works out. So, and there is not even a setting. So the other, I see this AB, class AB amplifier. Where is it? This class AB amplifier even has like a gain setting here. Sorry, my face is too huge here. Whoop. Okay, so the class AB amplifier, that's a cool IC. It's small and it won't have any solder bridges. I love this package. It's quad flat pack. Flat. How is it? Quad flat? Yeah, something like that. It doesn't have any solder bridges. So and it has even gain setting. And I even connected the gain setting to the ESP32, so we'll be able to set it in software. Oh yeah. Blowing out up headphones. Okay. Yeah, maybe I should. It's even, if I use this class D amplifier, maybe I should add a connection for an external speaker. Okay, I will do that. You know what? This isn't great here. How do I do it? If I connect this to ground, if I don't, okay, I can connect it. So let's do it like that. Let's call this Alt P, and we take, oh, can you even, so small, okay. So we will change that, and we will add like a pin header. Oops, that's the wrong one. A pin header to, I hope the output isn't biased. I hope this is like, this will work as a line in. If it won't, then we might have a problem. But the most amplifiers should work with, should be able to remove any bias. Out negative, and then we add another connector. Not EV library, male connector, male header pin header. This is the female. Okay, let's do a, should we take a, I rather take a female. I rather take a female connector, since it could be shorted. I don't want the amplifier to be shorted. It doesn't matter, I won't provide the connector anyways. You can simply solder some wires to it to connect the speaker. But we added a connector here and add like the, you will see I have the layout of the board already. So, and I still have some space close to the headphone jack for where this connector could fit. Okay, so I took some time before today to convert this complete stuff. Maybe I will explain a bit. This is the button to be able to program the IC. This is the host IC. This is the USB female, USB-A female jack. Then we have, this is simply male 2-row 3 pins a row connector to be able to program and test the board. And then we have the power. So maybe, I don't know if you knew it, so I'm using like a USB, micro USB to power it with 5 volts. I don't care about like doing like a LiPo connector or something with all the circuits. You just take a power bank and use it on the go with the power bank. If you like, you need like a power bank with maybe not so much noise, but you will figure it out yourself. And then to be able to get like quite some power from the USB, you have to put like the 200 ohms resistor between the plus and the minus. Yeah, Aska, USB-C, the connector is larger, the pin pitch is smaller, and it doesn't add any value except for like you can flip it. And I actually don't have many like power supply, USB-C power supplies. I could like use a USB-C cable, but I'm not sure. I rather, it's like a super rudimentary, like a basic project for now. I don't know. Maybe we could switch it to USB-C at some point. Oh, we have the coronavirus already. It's in Germany, and we have like 10 cases of coronavirus. Yeah, but 4 amps, 20 volts. But you need like a logic. You have to negotiate it. Do you have like a circuit for that? If you have, I would be glad to get like a circuit. There are some cheap China circuits that probably doing that, negotiating that's the highest voltage and power you can get from that. But I don't want to handle 20 volts on my side here. I'm glad I get like 5 volts and doesn't need to care anymore. It's like only putting the resistor between the D pins to get like all the current that I can get is good enough for me right now. Flippable. Put 2 opposite micro USB. There are even connectors. I have a cable that's flippable and it's micro USB. It's like this like this wedge-shaped corners. Yeah, yeah, electrocute, like 20 volts, like electrocution between the ears. Fry the brain. Okay, so we added like a connector here. This is the amplifier, this is the jack, this is only for power, and this is the DAC. So 8-bit DAC. We will get a problem. There is no much like quality to the audio if we have to use like volume in software here. We end up having like 1-bit or 2-bit output if the volume like blasts out your ears here with this amplifier. Or we might want to. We could also put in some like voltage divider here. That would be possible between these two. Huh. Huh. Maybe like a small surface mount potentiometer. But do I have some here? Yeah, I have some here, I think. Good idea, isn't it? Yeah. And then you will have like super noisy. If you turn this down, you will get like super noisy output. Oh, will it work though? Because I see the problem. The impedance here differs. Better with 2 resistors. Yeah, we can. Yeah, we can test the circuit before. I will do it. As soon as I get the amplifier, we can breadboard this circuit and test it beforehand. But then I have to like... Oh, Brian is back. Okay, yeah, 2 resistors could do the job right now. We not necessarily have to populate them right now, so we could take any value. So, oh, you are crazy fast with your videos. I'm jealous. Or I'm envious. Rendering first pass. You're doing 2-pass rendering? Okay, so we will do like a voltage divider in between. At least we can prototype it. It doesn't hurt. Like here, resistors. We need 2 resistors. Oh yeah, it does hurt. We need at least one 0 ohm resistor here. 0 ohm and then infinite ohm. 1 mega ohm. Or do we divide it up front like we can is it like this? So does anyone see a problem dividing the voltage here after the DAC? Because I don't know how the impedance is here. Might be problems with the DAC here. We probably would need a buffer in between. Opinions on that? Might be the problem that we won't be able to do it like this because of the varying impedance on that side. I don't know what the word impedance means, sorry. I'm probably wiring tools, yeah. Oops, it's not connected like that. No, not a buffer. I could, but should I? The question is if I should. What does IIRC? It's resistant based on frequency? What? Or a rather big impedance in the divider. So I took 1K and 2K resistors here. And I saw like if I take 10K, 20K, doesn't work well with the it's too slow afterwards. It could be fast enough for audio, but how does it affect the voltage divide afterwards? Oh, if I recall correctly, yeah. Okay. Got it. You got 9K impedance at the output of the R to R ladder. Okay. And now I'm a software engineer. Help! Oh, I see that failing here. Okay, I got for now I have like only this 0 ohms resistor here, 0 ohms, and one mega ohm for here. So now it will simply do nothing. Maybe even not populating this. I just need to don't forget about PAM input impedance around 10K. What does it mean? What? Ah! I'm such a noob. Where did you see it? 10K impedance. Do you know this IC? Or did we see it somewhere here? I'm adding a filter. Oh no! Page 7. Oh, Page 7. I see the first problem here. I see the first problem. It says audio precision system generator. Precision. In order to not disrupt the signal going to the amp, you have to pick big resistance for the voltage divider. Okay, cool. Yeah, that's the information that, yeah, that helps. Okay, oh, yeah, the filter cap. The filter, oh, there's so much text. Oh. Did I tell you already that I can't read? Oh, there are some calculations, and they are talking about the phase and something like, oh, there is like here a formula, capacitor. Ah, well, input capacitor. Okay. This minimum impedance and from high pass filter, the corner frequency determined by the following equation. It's important to choose the value of, oh, for example, when the amplifications required a flat bass response as low as 100 hertz. Are you kidding me? I should throw this away. These amplifiers here. my hair. I should just cut it off. Or use like a lathe or something. Mm, 100 hertz. So we have 2 pi f as an input resistance variable for the CI value. Wow. I feel like a complete noob. Oh, we have here some info about for filtering lower frequencies, noise signals, capacitor, blah, blah, blah. Closely located near, blah. Okay. Okay, now let's do the chat do the work here. In order to not disrupt the signal going to the amp. Okay. Can't read wrong. Okay. PZ 314. Don't forget about PAM impedance 10K. Okay, yeah. Page 7. About input filter cap and forming a high pass with the internal Z in. Then they mention the input impedance is variable. Where do they mention it? Oh. Increase to 10 microfarads. But they say if the input impedance is variable, I should only use like 0.1 to 0.22 microfarads. Oh, I hate this amplifier already. That sucks. Maybe you should use only the stereo amplifier, but then I don't know what to do with these that I have 200 ordered already. Okay, so any recommendations? What should we do here? Should we switch that to 10K and 20K? Yes, no? Probably. We can. So you say 10 microfarads. That's the ones that I have used before. Okay, 10 microfarads done. But what about the minus? Should we change this to 10 microfarads as well? Probably. It's like the input, it's differential input here. Or no, it's not differential. Yeah, it is. Oh yeah, footprints and test the values in practice. Okay, yeah. Yeah, that's probably what we should do. Don't do theoretical stuff for ages. Okay, so PZ, do I change this value as well to 10 micros? Probably, don't I? Like that? There should be similar. Then we leave that like this and we change the impedance here to be higher. Okay, yeah, but when we have like a super high impedance here, so like here's like very not much current going on here, and then we have to charge like 10 microfarad capacitor, we get like that's like a super either like, isn't that a low pass then? It seems for me like it's a low pass filter. No, it isn't. Is it? No. Oh. I'm an imposter. Now it's official. Ah. Tomorrow, a new Hackaday article. Bitluni doesn't know what he does. I simply put random components in and check if it works. If it works, then it's fine. And okay, so what is this crap here? Okay, like that. Okay, so we have the caps, but will it work with 10K and 20K now? That's the big question. If I switch to 10 and 20K, I even have maybe 10 and 20K there. It will be really tedious to change it. Did you know that you can, maybe I will switch off the chat so you can see it. So if you use like, maybe some few tips, if you start your selection from the bottom, it will select everything that it's touched by the selection. And if you start your selection from the top, it will only select everything that's completely enclosed by the selection. So that might help. And also, so I will simply like do this selection here. And then with control, you can obviously add another one. So I selected every single 2K resistor now. And the editor is quite convenient, even allows you, it shows like the prefix differs from so you have multiple different prefixes here, but the value of 2K is the same. So I can edit the value and it will change for every single resistor there. Cool, isn't it? It might help with the editing here a bit. So now let's select. Did it work? No, it didn't. Can we select? Yeah. 1K resistors And oh, it selected like some wiring as well. That's crappy. Okay, now I will use control to get the resistors only and 10K. Okay. Should be okay. Okay, so it's like a super crappy amplifier then. Let's store it. I only have a half an hour left, so we should be able to at least finish that board here. Synthesizer board. And I have the PCB that's generated already, and I placed everything except for the new components. So we will update. Are you still there? Is the chat still working? No. I don't know. Okay. So I placed everything already. No. Okay, so I placed everything already. I didn't do the wiring yet, so oops. We have still some stuff here, and we can add the new stuff here, and maybe here's some components for this filtering for this resistor ladder. But I mean the divider. The divider. Oh no! I hope that I don't have to place the values again. Okay, let's see if we can update the board. No. That's something that's happening only recently. I don't know why. That's like a bug that happened that only happened recently. Started happening recently. Know which resistor it is. Let's do it 20 and 21. It shows like it doesn't change this. It doesn't change the prefix properly, so it has like 2 times the same prefix. It's bad. So it's, oh man. Okay, what's the last prefix I got? Maybe I should take a look at the BOM here. Oof. R20. I don't see R21. Oh no. Okay, let's do it 31 and 32. That should work. Okay. Auto route. Yeah, I have used that once. Oh yeah, okay. It kept the placing of the resistors. Oh, that's great. Don't tell me I should use KiCad. It's so convenient working with this easy EDA. It's really easy, especially for such noob as me. Oh yeah. Last resistor. Okay, this is our new jack. So my plan is to have like the board outline really sucks here in this tool, but we will put in the, where's my board outline? Yeah, okay, start at 0. Okay, but we will make it this big. This will be the board, like this. And now we have to put in our voltage divider. Oops. This is our amplifier. It's really cramped already here. Okay, I want here, since it will be simpler to work with later, I want to be the value displayed, not the prefix. That helps if you place by hand, because there's a step less to look in the list in the BOM on the BOM file. So this is the cap. These are the caps, the filter caps, and this is the divider. Crap. I need to move it a bit more downwards, but it's quite close to the edge. I don't want to cause any problems there. I could maybe move it here and rotate these ones here. Okay, this will work. Will it? No. I will route them output. This will be a via maybe. I can move this a bit up. Yeah, but it's on the corner. I don't like it either. Maybe we can shift it a little bit further down later. This is the cap, the filter. Like move it over here. Then we have the 1 million. And where's the 0 ohms? 0 ohms can be here. Is it right? Yeah, that should work. Yeah, but that is, I will change the order. Wow, this is the million. I should move it a bit away. I need the silk screen here, so I will make it smaller. I will make it 5 width and do it like 30. 30 is enough to be still visible here. So, oops. Oh, you can see anything because of the chat. What is over the phone? Press on the last resistor in the ladder. What is with the last resistor in the ladder? This one? No. What? What's the problem? Ask her. Okay. Okay, are you satisfied with me clicking on the resistor? Okay, let's get back here. So I will change the size here of the font and I will make it thinner. Okay, so I will put the label in here. 1M. This is also too huge. Yeah, 5 is okay. Does it work? I don't know. So this is the filter cap here, 30. Oops. Okay, it was a little bit too small. Okay. Or should I move it a little bit more up so it's closer together? Yeah. And put it below that. Like that. Yeah, they are less important if I get it assembled. I don't know. I will probably have to do fixes on that anyways before I get assembly. I will, like, the first batch, if this works, I will get like, this is stupid. Look at this. The marking is outside. Yeah, I will use my pick and place for that. Yes, Brian. Oh, it looks chaotic right now. But we were able to... How close to the edge should I put this? Should I put it this way around? Oh, yeah, maybe I will put it like that, but it's too close to the USB power. No, that's too close. I will rotate it like that, because then you could even solder on a JST connector. So I will move it a little bit in like that. And you could connect like a speaker directly here, not using the audio, maybe even not populating it. Luniconta 2 has to happen. Yes. Aaron has to help me. Okay, what I was talking about earlier is, yeah, if this filter caps, the power filter caps, 100 nanofarads here for the USB stuff, then 100 nanofarads here for the one power array. This is the second power array, 3.3 volts. Here's all the where is this from? Oh, this 10K should move up there. I need to rotate this and make it smaller as well, maybe. But this will be okay. Yeah, there is like, there are all like 10. Maybe I could even move it more up, but I don't want this resistor or this capacitor be too close. Oh, but that fits. Is it too close? Hello, Sin. Is it too close to the... I want here some space for wiring, since this will be tied anyways. So this might be a little bit too close. TX, RX, be some wiring here. Maybe like that. And now we have like two 100 nanofarads here. Okay, I will do this font a little bit smaller here. Nobody needs that so big. 5. That's too huge as well. It's just... this as well. Just takes some space. No. The wiring on the bottom layer, what? Yeah, but yeah. For the audio, I don't want to make any wiring, like avoid additional wires, because the traces should be as short as possible to not induce any noise. So I want to be really like tight here, everything. I don't want to have many wires and get like from maybe a battery or something on the bottom, get like on a single audio digital audio channel an additional like noise source. But this year I could put them definitively on the bottom side. Okay, this is the fuse. That's a responsible move, isn't it? To put a fuse to the USB connector. But it was in the reference circuit, and it's a polyfuse indeed. So if it doesn't break. Any bad experiences with polyfuses? Yeah, but Arduino Zone, I won't use JC PCB assembly probably anymore, since the boards are great, but the assembly is currently still a little bit limiting. So you can't place like connectors, and I need like 3 connectors here. So there are other assembly services. One of them I'm testing right now, and you will get a video on that if it works out quite well. So I'm trying to do my like camera programmer. I placed an order at a different supplier there to make it to get it done, since I was really tired of soldering USB connectors, and I can provide you a lower price once that is done correctly by the other company. Okay, so I can move this power source here up, so we don't have here like close to the pins. This is 200 ohms, smaller. Oops. Test points for troubleshooting. Yeah, I don't have test points, but I have this connector here. This connector here is completely only like you could program the microcontroller, and you got also UART, so you can do debug output and stuff like that. Yeah, it would be easier to have like test points here. Maybe I'll put additional test points here to get like some cool measurements. Yeah, you are right. I will add a test point here. How do I do test points? Just the pad, units, surface mount. Where is that? Visible copper zone. Yeah, but let's root first, and then if we have some space, I will add some test points. Okay? Deal? So at least for the debugging of the USB, we have here, and programming, we have like this stuff. And then for debugging the amplifier and the steps in between, we add some test points. You're right with that. Especially if we want to troubleshoot. Hello, Bolly. Routing first, and then whenever we have some space. And I have only 15 minutes left for now, because I have an appointment with my girlfriend to do cooking. And I don't want to abandon her with the quest. Prefix display not needed here. USB 2, USB 1. Do we have a prefix display here? Like that. Yeah, we will cook some beef today. Cooking streams. Okay, it looks nice so far. How big is it? I have like switched to millimeters for a proper measurement. Yeah, 20. Wow. Oh, if I make it a little bit smaller, it would fit like 4 times in a 10 by 10 centimeter. So I could push this a little bit back. So the board outline. Yeah, it could. Yeah, it won't fit like more than, yeah, to have like a 10 by 10 panel, we can make it shorter. Let's set the board outline. 25 only. And oh, we need to make it shorter as well. No, but we can't get another 5 millimeters. We would need like, yeah, something like that to get like a nice panel. Oh, that's not possible. Crap. Yeah, but I want to have like borders with for pick and place. That won't fit. Even while I move it like this and I somehow no, I will never put this on the back side. Okay, let's change it again. I will only change the width for now. No, no, not penalizing first. It will have changes anyway, so let's only change this so I can get like 2 boards more from a panel. That's still good enough, and I have only to move like 1 part here. That's good. Oh, okay. Yeah, that won't work. The USB connector. No, I can pick and place this board. Okay, so we got a problem that the USB connector, it's like the lower corner. I don't know if I will be able to show this. So the lower edge of the connector is bent downwards. So I have to make like a cutout for the board. Yeah, but I need a cutout either here, so move it further in and do the cutout. But then if I want to make a case for that, we don't have like the case has to be like have a really thin wall to be able to put in the connector completely, like or also it's the best to have it stick it out like that. So I would need to have the cutout on the other side of the board because I want to penalize it, and that's not happening here. Do you see there's no space whatsoever? I will do it on this side, okay? Whatever. It's a crappy board anyways. USB-C. I could use a different connector for that, but I have like a complete reel of these USB connectors, and that should. Okay, and look, it's so easy. Just clicking here. Whoops. Double clicking and get a point, additional point here. But boop. Oh, ooh, I have to change the attributes. I should do the wiring first. I'm wasting our times with that. Grid size, snap size, 0.1 millimeters. Update, okay, yeah. That should be cool. Further in. Rabbit hole. Oh, I'm in the rabbit hole since 3 weeks already, guys. Okay, no double clicking needed. You just need to move the points, the center point. I think we are still in line here. Yeah. Okay, like that. That should be good enough. Shouldn't be, shouldn't it? Oh, that's okay, I think. Okay, that's that. Let's connect stuff. We need, I will put some, okay, please help me with the ground planes. I don't know if it's, should I put ground plane everywhere if I do audio stuff, or should I just keep it clear? Help. I need help. You know, Brian, ground planes are much easier than wiring every single ground wire. I don't do like design manager and do the nets here. You can't make a panel with this cutout if you want to be V-cut. Why not? The cutout is too small. Okay, let's try. I don't care. Oh, if they don't cut it out, I won't be able to place the connector in. Oh. 1 millimeter. Okay, how much do we have here? Oh, okay. We need like a little bit more. We are almost there, guys. Almost there. But thanks for the hint. Now we will really screw with our... Oops. Really screw with our case now. Like this. Like this. I'm cutting out like this because if I want to pick and place it and have a panel and the USB connector has like a small band, so it will probably, if I don't do it, it will probably sit like on the board and it's a little bit tilted since it has like this band in this outer edge. Or should we just ignore it? Oh no! Psst, psst, psst. We will do some wiring. I still have some time. Okay, let's do wiring. You want to see wiring? Let's do wiring first, yeah. Like this. Ah. Auto route. Will fit. auto routing. Loony root will be like using I squared S to root faster. Oh, damn. Yeah, but guys, you helped me a lot today with the amplifier stuff, with impedance, which is like, for me, is like magic. In German would be like Hexenwerk, is the proper word in German. So, like a witch work. Is it common to say it like that? Yeah, thanks for the distraction. So I have to take care that I don't wire by accident like this ground stuff. Okay, this is what I wanted here. This is, oh, there is a ground stuff here. Like that. What else do we have? This was planned to be like, this is ground. This is okay for me. Like that, 5 volts. Now it's starting to get annoying. Okay. Now let's do the channels here. Is there a key combination for disabling or changing the fill of ground planes? Do you know, or planes and all? Do you know something like that for easy EDA? What is this? Enable. Did I root that? Who the hell roots an enable pin? With smooth edge here. I don't care. Okay. No time for OCD right now. Now I press B and like that, and T for top, and we are fine here. I'll maybe shift that a bit. Okay, enable pin is done. Now, which one is this? This is ground. Ground is okay. That doesn't matter. 5 volts, 5 volts, USB 5 volts. I don't have an additional plane for 5 volts, but oops. What's that? Damn. Then we have button. Then we have here the filter for 3.3 volts, even though we don't need it. Maybe I should just skip it. And this is the fuse, and we need a thicker wire here, I think, since this is this power supply with, let's take 5 millimeters. Bam. Then we need like this data. Ooh, it's still like in this. Come on. 2.54. Okay, yeah, back to normal. I have no design rules here. Ground doesn't matter. Yeah. Where the hell is this going? I think we should do the 5 volts on the bottom. It's okay here for this filter stuff, but we have plenty of space here. We shouldn't like put it far. Oh, we need this. Oh, we need the space. Oh, that's wrong. That's wrong. Sorry. I kept the space for the data lines for the USB stuff. No, this is ground, isn't it? Yes. No, it doesn't need to be wired. Crap. Okay, let's do it like on the bottom layer. Pressing B. Going in here. Like that. Top and done. Next one. B. They have to be like, they are differential. Don't they need to be like close to each other? And not differing length? Yeah, but it's not like super high speed USB that we are doing here. So the length should be the same. There is even an option for wiring differential pairs in Easy EDA. Oh, what is that? Oh, that's something I hate routing in Easy EDA. That sometimes it doesn't do a good job. Like, okay, that's good enough. Yeah, hello Luigi. Yeah, that is like the super simple micro edition for now, but it's not very small. It's like it's 2.5 by 4 centimeters. Okay, button 5 volts. Let's check how many. Oh, yeah, we have done much stuff in the last 7 minutes. Okay, now we have to route this connector here. I think I will do this on the bottom side. That's not really important, and we have a through hole stuff here, so it's easy to route that. Yeah, can you see anything? Yes. Okay, bottom B, and which is TX? Doesn't show here. Put it like this, top, and then it's going back and forth there. This is TX, then we need RX, bottom B. We need to go there, so we are going like this, there. Yeah, switch to top, like this and that, and we are done with TX and RX. Reset. I never used the reset of that one before, of this CH559, but it says reset, and I will just use it. Maybe we can use it as an additional IO. So move to bottom layer, and oh, we might want to stay on the top layer there at some point. Maybe we will go over here, since we need to route 5 volts on the bottom layer as well. And I want to keep the bottom layer clear as far as possible. So button pin, oh, that's going across the complete board. What's that? Who designed this crap? Okay, let's do it. Okay, let's do it like this, then go close to that one, then go here, do the wire. No, that isn't good. Okay, we do it like that. We move the reset wire over there and do the routing. No, doesn't fit. Like that. And bleh. Don't judge me for this corner here. Yeah, whatever. Oh, maybe we move simply Rx further down and then it's okay, isn't it? Like moving that up again. I don't care. Okay, there's like a slide corner, isn't it? I don't know. It's okay. Perhaps it would make for a neat little music box if you add some memory for MIDI files, make it self-play. Yeah, that's actually a thing I want to make for, but it's another project. I had a request by a Patreon of mine for doing MIDI stuff, MIDI file stuff, and you missed that at the beginning. I was talking about a different synth. This is the actual synth, and that one supports an SD card. So SD card and even the PSRAM memory rover module for the ESP32. But the PCB that I'm routing right now, that's a simple without even the ESP32. That will be definitively like a super rudimentary synth, since it doesn't have any memory left. So it's like only creating samples, and like the memory will be just stuffed with the notes that are currently pressed down. Oh, yeah, cooking. Yeah, I know. I'm almost there. We have like few nets left that have to be routed, guys. No pressure, please. I'm almost there. 5 volts. We need only 5 volts here. Oh, we have the complete output to do the complete output on this side as well. Like this. And out negative and out positive. What? Oh yeah, that's wrong. I have to change the here. There is the out positive. That was a slight error in the schematic. And we have to update. I hope it doesn't break. Yeah. Okay. Yeah. Since this should be okay, there is. Whoops. What's the problem here? Oh yeah, the wiring is out. I have to replace the wiring here. Rather like that, and connect this again, and then we have the output positive. I will route it here. Like that here, this corner, Dave. Yeah. Oh, I still want to do like a super OCD triggering version of a project where all the OCD guys like one of these resistors has like, here's like a slightly bigger gap or one resistor is like tilted by 10 degrees or something. Like a super triggering stuff. Okay. We have nets out N, whereas there's negative missing somewhere. Yeah, this one here. Out negative. Oh, there's no way we can route this properly. Can we? Yeah, bottom side. Okay, let's do it. Yeah. No time. Ain't nobody got time for that. You know what? I will simply use this as a wire. Ah, okay. That worked. Okay, now we have grounds. Oh, there's... Oh yeah, these three. I missed that once here. But fortunately, whoops, what's happening? Fortunately, they have enough space and room and no abstractions or anything. We can simply wire them like that. Isn't that neat? And the last one, there's still enough space for an LED or something. I could place an LED there or something. Nice. Okay. Yeah, we were like chatting and for like 2 hours, and then within like 20 minutes everything is routed or what? Guys, what's up with that? Now we have only 5 volts and ground and some labeling. I would need to label these pins and add some test pads. We could add test pads here and some test pads here. But this is something I won't do right now because I don't have any time left. But I will do the 5 volts now. So I wanted to do the 5 volts on the bottom layer. So let's start with like here and bottom layer. Oh no, this one can be routed on the top layer still. That's good enough. That's just a pull down or pull up resistor here. So no worries there. And yeah, here let's start on the bottom layer. Oh, yeah, okay. Let's start here. What's that? That looks crappy. Now it's tilted a bit. Dave, what do you think? Minus 15 minutes left. Brian! I will clone your project. If you don't, if you are mean, I will clone your project. Ah! So, bottom layer. We are on the bottom layer now. And here is the one. Choop. Power line. Okay, this has to be like... Okay, maybe we should design rule, like add a design rule. Which one? Default? No, not default. 5 volts, not default. How do I? Five, like that. Oh, nah, this is okay. Design rule 0.5. Clearance, this is okay. What? No. Oh, come on. I didn't want to drag and... Okay, I was praising. I know what, I will do it. Do it live. Let's do it live. Okay, 5 volt. I don't want every single... wow, that's thick. Okay, that's too thick. I don't want every single line to be like super thick, but at least when we get some current to like burn your ears. So 5, oops, 4, like that. Oops, what's wrong with that? Okay, yeah, that's obviously, this is just a pull up. This doesn't need to be thicker than the others. Yeah, thick. Okay, bottom layer. Let's start here and go here, and the top layer, and what? No. Huh? Oh. Yeah, no. That's not where I want it to be right now. Something like that. Yeah, the 5 volt directly beneath all the audio stuff. That will be nice. You get like this special effect. Nice noise. Crap, 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 crap. Okay, we still need like 5 volts here, 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 and here, and here, and here, here, here. We will move the reset up there, so we have plenty of space. Yeah, thank you for nothing. Whoa, that's a thick wire here. Thick. That won't fit there. Okay, let's do 0.3. That should be enough there. And we can do like 3 there. What? Oh yeah. And we still need the 5 volts here. Yeah, we can... Oh, wait. Here. There's plenty of space left. We can even use like... Doop. Like super thick. That's a line. Okay, I don't think we need like here 0.5. That's 0.3. It's triggering that everything has a different size, and there is like not a corner, and like that. And this point will appear on the other side probably when I penalize it. Okay, do we have every... Yeah, 5 volts is done. Now, guys. Oops. I want... Not a copper area. Yes, a copper area. Ground. Cool. That's a new feature. It didn't ask before. It just assumed. Okay. Copper area done. Keep islands. Yes, no, maybe. I will make it like this. Bottom layer. Okay. Dip, dip, dip. Oh yeah, that felt quite nice. Oh, there is 5 volt missing. What's that? What? No, the mega ohm is between ground and I don't know what they want. It's probably not updated yet. Okay, there's or maybe the disconnected ground plane. That could happen. Okay. What's that? Ground. It's a disconnected ground plane. Yeah. Okay, now we have to set some vias here, or vias, or whatever you like to call it. We will do a ground. This will destroy our silk screen, so I will put it somewhere here. And now we have to set GND. And now it's connected, and I will put some vias here, there, and there, and there to not create like some, oops, it's too close. Yeah. Maybe here. Then create maybe here so we don't have antennas all over the place. Here, there, there. And you don't want to place them like super correctly, since you will get like resonances probably. I don't know. As you have seen, I'm an imposter in electronics, so I don't know anything about resonance frequencies, antennas, impedance, and stuff like that. Okay. Yeah, that's good enough, isn't it? Like here, there, and there. Okay, refill, rebuild copper area, and rebuild copper area. Up. It's good, isn't it? Nets are connected. DSC errors. Crashed, not saved. No! Oh, yeah, we have some clearance issues. Okay, let's check the clearance issues. What's the problem here? Oh, what? Yes, no, yeah, that has to move up a bit like that. Okay, we have to redo the copper area here. And that one. Oh, the storm outside is like raging. I need to check on my garden since I have some quite, oops. Okay, that should be fixed. Yep. Is there a key for Hello, Zeus from India. Is there a key for recalculating all planes? Please help me. Oops. Oh, that's what I hate. If you click on this, on the arrow, it will select both participating parties, but I only want to move this one, so okay. Like that. Is it clear enough? Okay. Okay, now refill. Okay, only thing that's missing right now, board is finished. Let's take a look how it looks like. Only thing that's missing is any sort of like bitluni sign, and here for the connector we need some like labels, but that's not much work left. But I will not do that right now. Let's take a look at the mic. Or you are auch here. You are auch here. Yeah, you are here too. Okay, yeah, board is quite clean on the back side. I see here, maybe I will put in another wire here to fill that area, but it's quite crowded up here. Probably won't do anything. Maybe I could move like this down here and this further to the left or something to let it fill somehow, or even move this one up here so it will fill the complete area here, but that's not very important right now, isn't it? Yeah, I never showed it live before. Okay, and that's all for today. You have to rewind like 30 minutes to see everything. I will do this more often, since now my PC is powerful enough to handle the live streaming and the editing or whatever that I do right now at once. And I think maybe we can create some content. Okay, cool. Thanks guys for watching. I'm sorry for rambling about support and stuff like that. I might even cut this out from the stream because it's like not very, no added value there. No, we have to, we do Sauerbraten today. I don't know what's the name for Sauerbraten. And it has to like cook for quite some time, and we don't want to eat like very late. Sauerbraten. Okay. Marinated pot roast. Not bread. It's not bread. It's like beef. Here. Sauerbraten.
Sauerbraten.
Or marinated pot roast.
Marinated pot roast.
Yeah. Okay, guys. Thank you for watching. No, face intro. No, is it intro? Yeah. Thank you for watching. Here's the music. And I will do more spontaneous streams like that. See you next time. Bye. And now I will awkwardly look for the stop stream button.